Greetings STEM advocates and future engineers. We are
iTech,
representing class of 2024 from Stephen F. Austin High School, Sugar Land, Texas. My name is Ariana Casson. I am in the 11th grade and my team role is commander and electrical engineer.
My name is Daryl Williams. I'm in the 11th grade and my team role is graphic designer, researcher, and documenter.
My name is Reva Jogden. I'm in the 11th grade and my team role is 3D modeler and mechanical engineer.
We will be presenting our stock class ROV Torpedo.
Our underwater ROV was a collage of previous designs that mimicked rounded submarine shapes. By having our buoyancy devices behind the triangle, it additionally minimizes drag. Everything such as our splash of red and fish line has a purpose, and it was through all our team collaborations that we were able to finish with this sleek design. But the day before regionals, we were thrown a curveball.
Hey, what's going on?
We were so confused on what to do since the ROV could not pass the fourth hoop and we were running out of daylight. We at least identified that the ROV had too much weight.
It's just sitting there.
This is when we decided to put our heads together. We started thinking about different solutions. One was to get rid of our triangle formation at the front since the elbows weigh more than the normal CPVC pipe.
That was an obvious no-go, as it is one of torpedoes' most defining features, and we would have increased drag because of the inability for the ROV to pierce through the water.
So we then thought of reducing the whole ROV by 2 inches, which would reduce the weight. However, by reducing the vertical and horizontal length, we would have to redo the buoyancy devices. An added risk is that the height or length would be too small, and the motor that goes up and down would not have enough room to operate like our first design. We decided to do vertical length first, then to take care of the motors caving into each other, we decided to move the motor's outer board to prevent the issue.
We also wanted to see if the motors were all working around the same speed since we wanted to make sure each motor had the same amount of power. We performed a paper test to measure the strength of the motors and the amount of air they blew on the paper to make it move, though they were not the same speed at all. Each motor had different speeds, and that was because we noticed that it was the difference between the battery power. We tested the motors on a fully charged battery and an almost dead battery and saw about a 1.5 inch difference between the two.
We also identified that the black feather, which used for visibility, weighed down our ROV. Since Daryl performed the paper test to measure motor speed, I wanted to reperform it to see which one was allowing more current to flow into the motors. What we observed was that the SeaPerch cable was providing more power to the motors than the black alternative. Due to those reasons, we went back to the original SeaPerch cable while adding buoyancy devices.
When we ran the ROV again, we could go through the 5th hoop and resurface. We were so happy that with each of our solutions, we could get our ROV through the hoops.
We ended up winning the super regional competition and meeting the world-renowned astronaut Suni Williams in the process.
It finally felt like our hard work paid off, and we were so grateful for this opportunity to compete for Stephen F. Austin High School in SeaPerch. Although it was a triumphant first year, we are already thinking of what to do next for SeaPerch and the future of underwater ROVs. With our gained knowledge of 3D modeling and the SeaPerch events, we plan to enter the open class competition by creating a 3D model replicating an industrial ROV, included with lights and cameras to help navigate the courses better. This is to prepare for our main vision, the combination of aviation and underwater technology in case of nuclear warfare. With this idea, we could build deep water colonies for cost-effective relocation while being able to moderate and detect the nuclear fallout on land through flight. This is why we're named iTech, since we're detecting the RAD or radiation of nuclear fallout.
That's the final blue, just that part.
Welcome to our YouTube channel. Make sure you like, comment, and subscribe to see this beautiful Georgia compete. This is